Hello, everybody. Last year at SBCL 25, I presented an idea about user-defined integer types in SBCL. This is a kind of short status report. I wrote it down in about half an hour yesterday, so please excuse the graphics. They are a bit bare. If you imagine a machine word here with 64 bits, this is not to scale, obviously. You may or may not know that SBCL, for example, uses tags to identify whether it's a fixed num, whether it's a pointer to a structure or a vector of some specialized type and so on. So I reserved one of the free types, free tags, and put another 8 bits behind that to get 256 user-defined integer types of 48 bits each. So you can define, I have a new integer type, in this case here with 32 bits, which is appended after the two tags. What can you do with an integer value? You can use it to point into large arrays, for example. So you can simulate structures by having one vector that represent slots and having large vectors in these, referenced by this array, to store the actual contents that you want to address. The big advantage is if you have a low number of instances, the pointer required to index into these arrays can be much smaller than 64 bits. You can use 8 bits, for example, then it's a simple unsigned character field in C or something like that, which reduces space usage. There's another mode for two-level allocations. This has the advantage that reallocations, or better, extensions, are much faster and much safer with multiple threads because you allocate another large vector and just need to copy the batch vector around. The batch vector by itself will be 20, 30, 40 elements. One of the large vectors might have 1,000,000 elements. By using this two-level structure, you allocate a new 1,000,000 element vector and just reference it in the other one and have 1,000,000 elements to address again. This is how it looks like. There is a similarity to devstruct, which is on purpose, of course. You should specify how many bits you want to use for indexing. Why will be visible later on. And by presenting an initial size, you get this allocation beforehand, so you don't have to do as many allocations during actual runtime. Another example is using a fixed size vector. You can see here a hash value with 32 unsigned byte 8 parts. If the type is one of unsigned byte or another user-defined type, this gets inlined within a large vector. So if you say, I want to have 1,000,000 elements initially, the vector used for the hash value gets allocated with 32 million elements. And the different hash values just get appended up there. Then there's another mode where you have not one field, but another one, or even more fields. This way you can specify that the length isn't fixed, but is variable. So you can store file names, usernames, or whatever, and they get appended within a big buffer, which also saves a lot of memory. As the time runs out, I'm getting to the summary. The reason why I started this is I have a project where I read from disk a lot of text files and end up with a few tens of millions objects within the heap. Doing a garbage collection with that or even a save Lisp and die is quite time consuming. By just having a few very large vectors, it becomes much, much faster. And as the pointers get reduced to 8-bit, for example, or to 16-bit, depending how many different objects of the type are available, the space is also thoroughly reduced. I haven't finished rewriting yet, but it got from 20 gigs to 7 gigs. Thank you.